Good day, I'm Maile Matsiba. Welcome back to our channel. We continue with the 2017 study guide of our CIR 113 module. Now we're going to be looking today at example 2.9.1. Here we're going to be looking at pressure. Now the question says, what is the pressure in kilopascals exerted by a 10-feet column of water at 60 degrees Fahrenheit only due to gravity? And then it goes further to say the density of water at 60 degrees Fahrenheit is actually 62.4 pounds per feet cubed. So now when you look at such a question, the first thing when you need to look at is, what do they want? They want pressure, but now they've given us density, which is 62.4, and also height. Now that should bring to our mind that the equation of pressure that we're going to be using is P equals to rho GH, where rho is the density and the G is the gravitational constant and H is the height. Now that is our equation. We all know that also pressure is known to be your force per meter cubed, or rather force per area. So, but because of the information given here, we know we're going to be using P equals to rho GH. So now moving forward, our step one, we can say step one, convert rho, which is the density, and H, which is the height, into SI units. The reason for that is that they're given in American system of units, both are rho and are H. And the question says they want it in kilopascals, which is in SI. So the first thing we do, we convert our density and our height to SI units. So we can say H equals to 10 feet multiplied by 0.3048 meters all over 1 feet. That gives us, or let me just write here like we always do, 1 feet equals to 0.3048 meters. Now that gives us 3.048 meters. Now our height is 3.048 meters. Moving forward, now our rho, which is our density, we know it to be 62.4 pounds per feet cubed. Now as we convert it, the first one we convert is our mass, which is, okay, let me just say 0.4. I'll explain it better when I've put it up in place. Yeah. Now we're converting the pound into kilograms. Like I said, we actually are converting the units into SI units, and we know that this is actually the ratio of both the pound and the kilogram. And then we move further to now convert the feet cubed. I hope we remember from our high school how to actually convert something that is actually a squared or cubed. And so we're going to be saying 1 feet all over 0.3048 meters cubed. So that is going to give us 999.57 kilograms per meter cubed. And I write here, i.e. 1 feet equals to 0.348 meters. Yeah, sorry for the duplication, but yeah, it's okay. So moving forward, we know that now we have our rho, we also have our height in SI units. So we go to our step 2. Step 2, say calculate the pressure using the equation P equals to rho GH. So therefore, now when we get to solve it, we say P equals to rho GH equals to our density. We calculated it to be here. It's 999.57 kilograms per meter cubed. Now our G is our gravitational constant, and our gravitational constant in SI is actually 9.807 meters per second squared. Remember, it's acceleration. Yeah, so it's meters per second squared, and then our height becomes 3.048 meters. So yeah, the answer would be 29878.8505 kilograms per meter second squared. This is because we have 2 meters here. We have a meter and a meter. We have meter squared above here and a meter cubed here, which means this one is gonna cancel. We're gonna be left with meter underneath here, and then we have kilograms that stands alone, and then we have r squared that stands alone. But another very important element that one needs to notice out of this, especially in this one, is that this is actually pascals. Kilograms per meter second squared is actually pascals. So we can say equals to 29878.805 8505 it's pascals. Yeah, these units are actually pascals. Let me just write here that sorry about the mess there, but I think it'll still be clear. Kilograms per meter second squared is equals to pascals, right? So yeah, that is the information I had. There wasn't even a conversion here. I just used the knowledge that kilograms per meter second squared equals to pascals. Maybe sometime when we have time, I'll actually get to go deeper into explaining that, but that is actually pascals. So now they wanted it in kilopascals, which means we simply divide by 1,000 here, and then we have 29.8788505 kilopascals. This we can say is 29.9 kilopascals. So yeah, that's how to answer this question. I hope it was clearer, and thank you again for this time, and let's meet again in our next video.